Feature engineering is one of the most creative steps within the machine learning model building overall steps. Let us understand what is feature engineering and how do we perform feature engineering. What are the tips and tricks that are applied in the real life projects so that we can learn and we can implement them as well. If you look at this data has just two columns, X, Y. Date is there and we have sales. Daily sales data is available. Now, if you want to predict the sales, just given the date. Now, the date is a string variable here. Is it possible to predict the sales based on a string? Think from the machine learning model building point of view. For a machine learning model, if you give this string, do you think based on this string, a machine learning model will be able to predict what is the sales? If you give a string as input, machine learning model will throw an output, which is error. It will say that the input is expected to be numeric value. You are giving me a string, so I cannot make any prediction. So you cannot do any prediction by taking this X data while you want to predict Y. But if you observe carefully, whenever the date is about 25, let's say 26, 27, 28, 30, 31, the sales is high. Again, 26, 27, 28, the sales is high. Whenever the date is higher than 25, the sales is high. Instead of giving X directly to predict Y, if you give X1, if you derive X1 from here, what is X1? Day of month. If you derive day of month from here, and if you give this to machine learning model, instead of giving X, if you give X1 and try to predict Y, then the machine learning model will understand that there is a pattern here. Whenever the day is more than 25, the sales is high, otherwise the sales is low. Then the machine learning model will understand this pattern and try to build a model that will be a little bit more accurate. If you give X, machine learning model will not be able to understand any pattern. If you give X1, then ML model will give you a better accuracy. Okay. Now there is one more pattern. If you observe this carefully, now 1, 2, 3, 4, 5, whenever, let's say if you take these 2 days, the sales is high. Again, after 1, 2, 3, 4, 5, these 2 days, the sales is high. Again, after 1, 2, 3, 4, 5, the sales is high on these 2 days. Have you seen that? 1, 2, 3, 4, 5, sales is high on these 2 days. What do you think is that? Again, if you go 5 days before, again, on these 2 days, the sales is high. After every 5 days, for 2 days, the sales is high. Can you tell me what kind of pattern is this?
Maybe the
Weekends.
weekend.
On weekends, sale is high. So instead of giving it directly the date, which is X, if I give X1, which is a day of month, then I'll get better accuracy. In fact, I see another pattern. If I see week day, if I derive weekday, which is like Saturday, Sunday, Monday, Tuesday, Wednesday, and so on, every Saturday, Sunday, every Saturday, Sunday, every Saturday, Sunday, the sales is high. If you directly give date, the machine learning model will not be able to understand anything. If you, instead of giving a date, if you give X1 day of month, X2 weekday, can you come up with certain other examples which will impact the sales? Given the date, what else can you derive? I can derive what day is it. I can also derive whether it is weekday or weekend. What else may impact the sales? Think about it, everyone. Given the date, what else can I derive so that we can predict sales?
Month.
Do you think month has an impact? Do you think there are some products where in certain month the sales will be high, in certain month the sales will be low?
Yes,
Yeah,
sir.
possible. But is month directly given to you? No, you have to derive. What else can you derive from date? Tell me, what else can you derive that will impact the sales?
So
Everybody
any
must
particular
know.
festival.
Festival days, this is very interesting. Festival or special day. Do you agree the sales will be high during a particular festival? Maybe if you go to Kolkata or something, maybe during the Durga Puja, that time the sales will be high. Maybe if you come to some other place during Diwali, the sales will be high. Do you think festival will have a certain impact on the sales? Directly, if you give me the date, the model will not be able to understand. But if you create a new variable which says that this date is this festival, 26 January, there is one festival. Like that, if you derive the festival or a special day, then the model may get better accuracy from this variable. What else can you derive? Can you derive quarter from here? Do you think the sales varies from quarter to quarter? In a quarter, the sales will be high. In another quarter, the sales will be less. Can you derive, sometimes if it is multi-year data, you can also derive year. Maybe the last year sales was high or sales was low. This year sales is high. Are you with me, everyone? What I'm trying to say is directly if you give date in the model will not be able to learn anything. But from here, if you derive day of the month, if you derive weekday, if you derive month, if you derive festival, if you derive quarter, if you derive year, half year, if you derive all these new variables or new features from the given feature, if you engineer and create these new derived features, that is known as feature engineering. Sometimes the information is hidden in the predictor column. Do you agree with that? Sometimes the information is there, but it's hidden in here. We have to manually extract the hidden patterns and create new columns. Sometimes the information is hidden in the predictor column. Sometimes we have to manually is very important, isn't it? Do you agree with that point? We have to understand the business problem. Based on that, we have to manually extract the hidden pattern and create a new column. Machine learning algorithm, then it will use those new columns, try to improve the overall model accuracy. If you directly give the right column as it is, then the ML model will not be able to use it. But if you derive new columns, then ML model will use it, then you will get better accuracy. This process of creating new columns, derived features, is known as feature engineering. Next time when you hear feature engineering, do you understand what's happening in the background? All of you, do you now understand what is the meaning of feature engineering now? Creating newer features based on the existing feature that is given to you, so that that newer feature will help you to get a better accuracy of the model. For example, if somebody gives you a date variable, you can create weekday, month, you can derive date, you can derive year, quarter, half year, special day indicator. Are you totally convinced with this? Have you understood what I'm trying to say here? Creating new columns from the date variable. Are you with me, everyone? Yeah. Okay.
Yes.
Sometimes some of the data, let us suppose if you're talking about Ola or Uber, if you're talking about Swiggy, Zomato, I think the sales or the number of orders depends on the time. More than the date, it's the time, isn't it? Let us suppose somebody booked Uber at 12:53 p.m. Let us suppose at 12:53, there are 200 trips that were booked. At 12:54, there are 120 trips that were booked. Let us suppose if you want to predict the number of rides, this time variable is given to you. Do you think directly giving this time variable 12:53 p.m., 12:54 p.m., the model will learn anything from here? No. What we need to do, we can derive, what else we can derive out of this time? We can derive hour. Do you agree? In particular hour, the number of trips will differ, or the number of orders on Swiggy vary based on the hour. Maybe early morning, 4 a.m., the number of orders are very different from the late evening, let's say 6 p.m. We can derive minute, we can derive working hours, non-working hours, we can derive midnight, peak hours, etc. Geographical variables are given as latitude and longitude values. Those latitude, longitude values are simple, plain numbers. ML model won't be able to understand anything. From there, you can derive city, state, country, province, etc. Sometimes there are some categorical variables we can perform some kind of one-hot encoding. I'm going to tell you what is that. So to understand this feature engineering much better, let us take an example. So this feature engineering is like the last attempt that a data scientist puts. In some of the interviews, they'll ask you this question: you got certain accuracy, to improve it, what did you do? This is absolutely a practical question. You got your model accuracy, to improve it, what did you do? Then you have to bring in this feature engineering into the picture. You have to tell, I have used feature engineering. I have been given this particular column and we derived this, we derived this, we derived this out of it. That has improved the accuracy. This is this column and we have done this particular feature engineering. That has worked. So let us take one example case study and then try to discuss all these feature engineering concepts on that example. This is one of the data set that is again available on Kaggle. On Kaggle, the data sets that we are using are all the real data sets that are either shared by a company or that are either shared by an organization, which is authentic, so that we can face all these challenges and it's interesting to solve them. There is a place called King County in US. Within King County, there were several homes that were sold, and we have taken a data of, I think, one and a half year, all the homes that were sold in that one and a half year. And it's a simple exercise. We want to predict what is the right house price. Pricing team. Have you ever heard of pricing team? some of our old students have joined pricing teams in some of the companies. What do you mean by pricing team? What do they do? Let us suppose the home that you are posting on a particular platform for selling, they will give you fair price for that home or the car. Have you ever seen that ad or anywhere? Like we have an algorithm that will decide what is a fair price for your car or what is a fair price for your home or something. What do you mean by fair price? The price that is optimal. If the price is too high, then there will be no buyer. He will be at loss. That's why he will not buy. If the price is too low, the seller will be at loss. So the price has to be optimal so that the buyer is also feeling that he's getting at a good price. The seller is also feeling that he's getting the profit that he is expecting. Now, how do you decide the fair price? Or how do you decide the price of the house? Even if you come to Indian context, forget about King County. How do you decide the price of the house? Let us see. So here is the data. We have the house ID, date that it got sold, the house, and what is the price of the house. This is the target variable, which is Y. And what are the features? Number of bedrooms, number of bathrooms, the square feet living, the carpet area, something. Don't you think even in India, these are the factors that will influence the price of the house? Do you agree with that? The price of the house depends on number of bedrooms, number of bathrooms, the area, the number of floors, whether there is any waterfront, lake view or something. What is the condition of the house? What is the grade of the house? What is the terrace area, filth area? All those things will come, isn't it? Year it got built. Do you agree? Year built. Does that matter? Does that influence the price of the house when it got built? Year the house got renovated. The zip code tells you where exactly is the house. That also impacts latitude, longitude. Those are exact, that will tell you exact position of the house. So usually, even if you come to India, these are the factors that will influence the price of the house. Now, usually, how do you build a model? This is the target variable. These are all the features. Obviously, we will do data exploration, data validation, data cleaning, and then we go to model building, and then we finally find the accuracy of the model. So we take all the features, we take the target variable, we build the model. The target variable is house price. Is that a classification problem or is that a regression problem?
Regression.
It's a regression problem, isn't it? So we build a regression model and let us see what is the accuracy of the model. For accuracy, you can use R square, or if you want to explain it to a layman in simple terms, you can also use MAPE, mean absolute percentage error. For example, for a model, MAPE is, let's say, 8%. That means if the actual value is 100, MAPE of the model is 8%. What are we trying to do? The predicted values range will be 100 plus or minus 8%. That means the predicted values will be in the range of 92 to 108. Tell me the MAPE value for a good model. It has to be a higher value or a lower value. What do you think? The MAPE value for a model. It has to be as lower as possible, isn't it? It makes sense. Yeah. So let's first build the basic model without applying any feature engineering tips and tricks. As it is, we will take the data as it is, we'll take X and Y, try to build the model, look at the train accuracy, look at the test accuracy. So get the code file. Have I posted it? Today morning, I have posted this feature engineering files. All right. Let me get this. Let's go to the code file. What I want you to do is import the data set, and then you carry on with the basic verifications, divide the data into train and test, and then first build the first model, the initial model, the model that is considering all the variables without any tweaking or modification, and tell me what is the R square and what is the MAPE value for model, basic model, model M1 version 1.
$70% and 69%.
So the R square value happens to be 70%, 69, roughly like 70% R square. Usually R square, if people without the statistical background or if they are layman, it will be little difficult to explain R square. An easier one would be MAPE or percentage error, mean absolute percentage error. Or in simple words, average percentage error is how much? 26% is the error. That means if a home costs exactly $1,000, it is the actual price. Our model is predicting at what? Plus or minus $260. That means the predicted values are in the range $740 to $1,260. Now we have to put all our efforts to reduce this MAPE from 26 to maybe 25 to maybe 20 or even less than that, or even let's say 15% MAPE. Or from the R square point of view, increase the R square to 70 to 73 to 80. 80 is our benchmark, isn't it? 80% R square is must. So let us put all our effort to increase the R square. What we need to do is we have the data with us. We have several columns. Now I'm going to tell you some methods that will improve this overall R square that is already existing with us. Okay. Now let us come to handling the date variables first. Once you have the date variable, you can create something like month, date. You can derive year, quarter, half year, etc., etc. So we have the date that it got sold. This is the sale date, the date that house got sold. Okay. We have another date variable, not directly date. We have the year it got built. Now, as soon as you see this, there must be one idea that should come to your mind. Think about it. The moment you have year it got built, the year the house got built, what is that variable that is coming to your mind? You should include it in here. Think about it. You have the year the house got built and you want to predict what is the price of the house. So from here, what can you derive? Think about it. Everyone must think. If I know when was the house built, what can I derive out of this?
Age of the house.
We can derive the age of the house. Yes or no? How do you derive age of the house? You have year it got built. You have today minus year it got built. Then it will give you age of the house. Do you think age of the house matters? Do you think age of the house
Yes.
matters? Yeah.
Yes.
So you can derive age of the house. Renovation. Renovation. Like right now, renovation year is 1987, 2001, 0. When it is not renovated, it is simply given as 0. To bring uniformity in this, we can create an indicator of renovation, renovation indicator, which takes values zeros and ones. Okay. If the house got renovated, then the value would be 1. If the house is not renovated, then the value is 0. Instead of taking renovation year, I'm taking indicator of renovation. Now, once you have the sales date, you can derive sales year from there. Do you agree? Maybe the price of the house in 2014 is lesser, maybe 2015 is higher. Do you think this year has an impact on the house of the price? Is there a possibility?
Yes.
Maybe previous year was higher, next year was lower. Yeah. Maybe we can derive year, we can derive month. Date is not required, but we can still try. Maybe in certain months people are not buying, or maybe in certain months the interest rate is low. That's why the house price is higher. Possibility is there. So what are the new variables or new features that I'm deriving here? Look at this. Based on the date, based on the year built, based on the year renovated, these are the original features. Now these are the engineered features, new features. I'm deriving sale year. Does that make sense to you? From this date, I am creating the year that it got sold. Somehow I'm feeling that maybe this year has some impact on the house price. Sale month, say day sold. Maybe it may not have impact, but I'm still creating it. Age of the house. Indicator renovated, whether the house renovated or not. If it is some year appears here, then it will be 1. True means 1. If it does not appear, then false, it means 0. These are the new columns that I have created, new features that I have created. Now I will use these new features and rebuild a model that will be model M2. Model M1, I think probably has an R square of how much? 70%. Or in terms of MAPE, 26% was the MAPE. Now tell me one thing, in real life scenarios, especially when we are working with data set like this, even this is a real data. Is there a guarantee that you have created all these features, the R square must increase, the MAPE must decrease? Is there any such guarantee, or it depends on the data, it depends on the power of the new variables that we have created? Can I
Depends.
say for sure my R square has to increase? No, it all depends on if you feel, if you think this year has an impact, then only it will increase. If month has an impact, then only it will increase. If age of the house has an impact, then only it will increase. It totally depends on the data. It's nothing is in our hand, isn't it? It all depends on the data. So go ahead, rebuild the model. Tell me the results from model M2. What is the new updated R square? What is the new MAPE? Updated R square and updated MAPE.
It's same, sir.
It's almost same. And that is the hard reality that we need to accept. There are no shortcuts here. Simply, if we are creating like this, definitely the R square is going to increase, the MAPE is going to decrease. That may not happen always. Feature engineering requires a lot of research work. We have to go to King County, that place, and we have to talk to real estate agents. We have to talk to home loan agents and ask them from 2014 to 2015, during that time period, which month has higher sales, which month has demand, which month doesn't have demand. Then we have to incorporate that as a new feature. Do you agree? If we go to the ground level, if we talk to the business guys, then only we will get to see some information that is beyond this data, then we can incorporate it. Feature engineering requires a lot of research. Feature engineering requires a lot of creativity. Yes or no? Do you agree with that point? Once we get into the business side of it, then the learning that we have in the business, that can be incorporated here. As a matter of fact, business knowledge is important in almost all the models that we're going to build in data science. Now let's try a few more set of variables. The other one is latitude, longitude. Latitude, longitude will tell you what exactly is the geographical location of the home. Do you think the geographical location of the home has anything to do with the price of the home?
Yes, sir.
I think it has a lot to do. Not only in US King County, even if you come to India, let's say if you're in Bangalore, there will be some places where the price of the house is very high. If you go far away from the city, the price of the house will be very less. I think geographical location of the house has a huge impact on the sales price of the house. You must agree with that, isn't it? That's a common scenario everywhere. So what did I do? The idea that I got here, this is totally my idea that I'm trying to implement. So to bring out this idea, what did I do? I tried finding out what are the top 30 percentile of the homes. Top 30 percentile. That means I have taken all the homes. I have, I think that descending order. This is the high price house. These are all the highly priced homes. These are the 30%. These are the homes that are very, very costly, top 30%. These are the remaining 70% of the homes. What did I do? I tried drawing them. Even without drawing them, you can manage. So the green ones, these are the top 30% of the homes. The red ones are the ones remaining 70%. Do you agree? It seems that all the high priced homes are confined to a particular place where the low priced homes are everywhere. Yes or no? If that's the scenario, usually like if you come to this one, if you kind of zoom in here, what you'll realize is that is a place where almost every home is priced one. Yes or no? Especially here. See, very, very less. Even here, if you see this one, that is a place where a lot of homes are high price. Everything is green there. And that happens usually everywhere, not just in US. There will be spots that are posh areas where the house price will be very high. There will be spots that are having house prices very low. Now, my strategy is I'll try to find the center of all these high priced houses. I'll try to find the center of all these high priced houses. Let me call that as high priced house center or the city center. Now I'll find the distance of every home from that center. I'll find the distance of every home, literally every home from that center. Tell me if that distance D is higher, what does that mean? The price will be higher or lower? Think about it.
Lower.
This distance is higher, that means you're going far away from the center. If you go far away from the center, what will happen to the house price? If you go far and far from the city center, the house price gets low. And that is what my idea is. I'm trying to find the center of all these homes. This is the center, the black dot. And then I'm trying to derive the distance. The distance is square root of x2 minus x1 whole square, y2 minus y1 whole square. There is something called Euclidean distance. You can find the distance. And if I try to draw the graph, distance is here. As the distance is increasing from 1 kilometer, 2, 3, 4, 5, 6, 10 kilometers. And this is the price of the house. As the distance is increasing, we expect the price of the house to fall like this. However, it is decreasing. The price of the house is decreasing, but it's not the same way that we are expecting. Honestly, a perfect graph would have been if the distance is increasing, the price should decrease. This is a graph that you expect somewhat like this. Would have been a perfect graph. But here, if the distance is this, the price of the house is lower as well as higher. So this is not the right. Overall, yes, it is decreasing. Still, let us go ahead, include this distance in the model and try to find out what is the improvement. If we go back to the flashback model, M1 has a MAP of 26%. That was without anything. Model M2, we have handled dates. That did not help much. It's 26% MAP. Let us do M3, which is handling geolocation variables. What is the new MAP that you are getting? How much is the new MAP that you are getting?
The 71 and 70.
So that is the R square value. Now, if you
Yes, sir.
come to like R square is again 71, 70 little, but from the MAP point of view, almost the same MAP. So I would say there is a not much of significant. Yes, there is a little bit of pattern that was captured somehow, but that's not so significant that we have to give a lot of importance to this, isn't it? Again, if we go to the ground level, if we visit King County, then you will be able to come up with certain hotspots that may help you, isn't it? Maybe if you visit, like I did some research on King County, I found that there is a place called Seattle. Now, Seattle is the major city within that King County, and houses near to Seattle, they have a very high price. There are so many hotels near Seattle, the houses have very high price. So instead of taking the center of all the high priced ones, I also tried with Seattle city indicator. If the house is in Seattle city, then the house price is high. I tried doing that. That also did not help much. Again, if we go there and study, definitely we may find something interesting related to geography, and then we may include that in the model that may improve the overall model accuracy. Do you once again agree that feature engineering requires a lot of creativity? It's not a statistical problem that we are solving. It's a business problem. We are understanding the business requirement. We are understanding the business relation, trying to convert into a new feature and then giving it to the model, isn't it? Sometimes what I have seen is some people use mathematical transformations. Let us suppose if the variable is x, if x is not working, if you try 1 by x, suddenly it will give you very good accuracy. Or maybe x squared will give you greater accuracy. Maybe x cube sometimes will give you very good accuracy. Instead of using x variable, if you take square root of x, that suddenly improves the accuracy. Instead of taking x, if you take, let's say, log of x, that suddenly improves the accuracy. I have seen people using these kind of mathematical transformations and they work immediately like a jump. Suddenly the R square might jump from 70% to 75% within no time, very easily. But what I generally suggest based on my experience is do not use mathematical transformations. Do not use mathematical transformations. In classrooms like this, generally when people are teaching, they give you all these mathematical transformations as tips. But what I have seen in real life and real projects is the clients won't appreciate mathematical transformations. For example, if the accuracy improves here, let's say you have created one high price home center, from there you derive distance. Based on that, you have built a model. If the accuracy improves here, can you give a justification? Yes, you can give a justification because I have got that logic into my system. But instead of using x, if you use square root of x, there the accuracy improved. Client is asking you, give me the justification, give me the reason why. How can you increase the accuracy? Can you simply say instead of x, I have used square root of x, that has worked? Do you think that is accepted in the industry? Instead of x, I have used log of x, that worked. Do you think that is accepted in the industry? Or you have to give a proper justification? Model building is not just about improving accuracy, also give proper justification. So sometimes a log transformation, a square transformation, square root transformation, inverse transformation, they may work, but do not use them. But if your client tells you, he himself tells you, the client, they themselves are informing you that use this proper mathematical transformation, then only you can use it. Without proper justification, we cannot use this. Are you with me, everyone? Have you understood why am I warning that do not use them directly? They may give you better improvement, but are they accepted in the industry? They are not accepted in the industry. Maybe in a classroom like this, it gives us a kind of good feeling to improve the accuracy of the model, but in reality, the situation is very different. So we will just do a mathematical transformation, but I will not suggest you to do this in the real life scenario. Have you understood what am I trying to say, all of you? Are you clear on this?
Yes, sir.
Yep. Now, instead of predicting the target variable y, if we try to predict logarithm of y, I'm applying a logarithm transformation. Go ahead, apply a logarithm transformation. I think the MAP value now doesn't make any sense because instead of taking y, we are taking logarithm of y. Mean absolute percentage error will be anyway very, very small. Let us look at the R square improvement. Tell me what is the new R square value if you're building for logarithm. Instead of building a model for y, if you build a model for logarithm of y, is it improving? What is the new R square value? Go back to the code, execute this, and tell me. Is the code given there? All of you, are you working on that? What is the new R square value? Until now, the best of the best R square happens to be how much? The best R square was 70%. Now from 70%, with this one, we have jumped to 77%. From 70% to 77%. Is that a negligible difference or is it a huge improvement? It's a huge improvement, isn't it? But are we going to use this? Are we going to use this transformation? Are we going to implement this in real life projects? No, not suggested. Yeah, no, it's not a good idea. Instead of just taking y, if you take log of y, it's like almost some kind of mathematical magic that we have done because everything is like connected to some mathematical formulas. It's almost like we tweaked those formulas to get a better R square, but the model is same, isn't it? It's not going to give you the potential lift in the real accuracy. Okay. Now, there is one more technique that's very, very important and that works at multiple places. That is for categorical variables, you can use one-hot encoding. Let us see what is that. What are categorical variables? Give me some examples. One of the example is region, which takes value east, west, north, south. Give me some other examples of categorical variables. Gender, which takes values male, female, not available or unknown or something like that. What else? Job type, employment type, blue collar, employed, self-employed, unemployed, like that. Or maybe something like business. What else?
Education.
Education, graduation, undergraduation, post-graduation, PhD, like that. So these are all categorical variables where distinct categories will be there. We will not be able to order them. Okay. Now, if you have a variable like this, directly if you give it to the model, sometimes some of them are numerical in nature, but they should be treated as categorical. For example, zip code. Zip code is 50076 50077. Can I say this is higher than this, or this is lower than this, or these are just two categories? Think about it. Do you think this zip code is higher than this? Can we say like that? We have to treat them as categories. Yes or no? Do you agree with that? Country code 001, country code 002. We should not say 2 is more than 1. Those are two categories. Yes, those are looking like numbers, but they are still categories. Now, when you have a column like this, you cannot use it for prediction of the target variable y. A categorical variable which has 4 categories, you have to convert it into 4 variables which are binary. So from one region variable, you have to create region 1, region 2, region 3, region 4. 4 new columns you have to create. And each of the column will take 2 values, 0, 1. Every column will take 2 values, zeros and ones only. Okay. Can you tell me what are the values taken by, first, let's say customer 1 belongs to East region. So can you tell me how do I fill this row? All these have to take either zeros or ones. Tell me. How do I fill that row?
000 and 1.
So since the customer 1 belongs to east, what I would say, I'll put region 1 as 1, remaining all are zeros. Customer 2 belongs to west. What I'll do? 0, 1, 0. If customer 3 is a lane belonging to east, he's from east. So how do I fill those values?
1000.
Customer 4 apparently belongs to south. How do I fill those values? 0001. Customer 5, if he belongs to north, 0010. Now, instead of taking one variable with 4 distinct values, we are creating 4 variables. For example, there is very much high sales in west. There is very much high sales in west. Which variable is going to take care of that? Which variable is going to take care of that if there is very high sales in west? If there's a pattern which we observe that there is very high sales in west, which variable will take care of that in the model? Think about it.
R2.
R2 is the variable that is indicating the west, isn't it? If there is very much low sales in east, which variable will take care of that? If there is very much low sales in east, R1 variable will take care of that. So one hot encoding is one of the most strongest technique. Converting one categorical variable into multiple binary variables like this is known as dummy variable creation. Dummy variable creation, or it is also known as one hot encoding. Both are one and the same. R1, R2, R3, R4 are known as dummy variables. Either you can call this as dummy variable creation or you can call this as one hot encoding. One hot encoding is one of the most powerful technique and one of the easiest techniques. Do you really need to study that whether there is higher sales in east, lower sales in west, medium sales in south, very high sales in north, or automatically this one hot encoding will take care of it? What if there is very, very high sales in north? Which variable will automatically take care of that? There's a variable that you have assigned for north. What is that? R3, isn't it? One hot encoding is very powerful. Do you understand why? Because if there are any patterns, automatically each of these variables will take care of them. If there's a very, very low sales in east, R1 will automatically come into the picture. So instead of using region variable, which is one variable, you create 4 variables. And whenever there is a hidden pattern, the reason why one hot encoding is very, very powerful is wherever there is a hidden pattern among these categories, automatically these features will take care of them automatically. For example, in our data, there is a variable called zip code. Now the zip code is taking values like 90001, 90002, 90003. We should not think that these are all actually numerical values. This is zip code. These are coded values. Now what happens in a particular zip code, the house price is very, very high. Do you agree with that? If you go to any city or any place, there will be one zip code, the house price will be damn high, very, very posh area. From the business point of view, think about it. There will
Yes, sir.
be some zip codes, the house price will be very, very low. Now, the advantage of one hot encoding is you don't need to study them. Automatically, if the house price is very, very high here, there will be one variable that will take care of it. If the house price is very, very low at some place, there will be one variable or one feature that will take care of it. So how do you convert this one categorical field into several dummy variables? How do you do that? You can use a function called pandas.getDummies, and you give the variable, automatically it will create those new columns. And usually one hot encoding, what I have seen in my experience, tends to give you much, much better improvement in the accuracy compared to all the other techniques. The reason is wherever there is a hidden pattern, obviously there will be some hidden pattern. Definitely that one hot encoding will squeeze that out of the data and give it to the model. So until now, the best of the best R square, like if I ignore this, the best of the best R square happens to be 70%. Perform one hot encoding and tell me what is the improvement. 70% is the best R square. I think 26% is the best mate. Now on zip code, you try to perform the one hot encoding and tell me what is the improvement. So once you do the one hot encoding, what is the final R square that you're getting? What is the final map that you're getting after completing one hot encoding? Are you getting any error by any chance? Let us try to
Sir.
Yes, sir.
let us see. One hot encoding and then data means yes. So the error is feature names are already supported, improved in all of them. But your feature has basically our feature names. It is trying to tell us that our feature names are strings. That is fine. But some of the feature names are numbers. That's the error. So the error that we are getting here is some of the feature names are coming out to be integer. Those are not supported. If you want feature name to be sorted, validated, etc., instead of directly using these numbers, basically when there's an error, we also need to understand what is this error and we have to resolve it. Because in the real life scenarios, definitely you will get into situations where you will get errors and then we have to resolve them. Okay. So what it is also giving us a solution. Instead of using x dot columns, use x dot columns as type string. Okay. So here, this is our x. Now what we will do is we will try to use this x dot columns equal to x dot columns as type string. So now everything will be a string. It must work. Now it's working. Okay. Try this. What you need to do is right after this, you have to take the information from the error message that you got, and then I'm putting it in the chat window. Add this line of code right after that. And then if you execute it, then you will get the R square. Tell me now, by including this line of code, tell me what is the R square value, new R square value.
80.
Let me try to put that in the code. Wow. X dot column.
%80.
Converting numer or numeric column names into strings. Because I'm writing it newly. Yeah. All right. Now R square from 70% has now jumped to 80%, which is a huge lift, and that is what expected in one hot encoding. And MAP from 26% error earlier has now gone down to 19 or 20% error. Anything which is 5% left is a huge improvement in generally. And it is true that zip code has definitely some impact on your final price of the house. There will be places where house price is very high. You can identify them using zip code. So zip code has very critical information. Now we have passed it on to the model, and the model has felt very happy about it, and we got the better accuracy here. Okay. Now there's one more technique that I have seen very frequently used. That is called binning technique. What is binning technique? Sometimes what happens is there is some inconsistent relationship with the target. The X variable, the feature, has some place of the feature, it has some consistent relationship. That means it is showing good pattern. At some other places, there is inconsistency. Because of that, what happens is the overall model may not be giving you good results. Let me show you an example. Let's say if you see here, X versus Y, if you're trying to predict the target variable Y using the X variable, as X is increasing, Y is increasing, in this one, you will get a very good regression model. But after a point of time, as X is increasing, Y is not increasing. Let us suppose this is the number of cold calls that you will make to your customers. These are the number of leads that you generate. But beyond a certain point, no matter how many cold calls you make, the leads are not generated. So here there is a good pattern, here there is not much of pattern. But if you directly try to use X for prediction of Y, you will get a pretty poor regression model finally. But instead of directly using the full range of X, you can break this range into how many pieces? Tell me. Instead of directly giving X, if you build a model only from 0 to 600, then it will be a good model. Maybe from here on, there is not much of pattern. If you directly take X completely and try to predict the target variable Y, then the model may not be good. But at least half of X, if you break the variable X into two pieces, at least in one piece, the model will have good R square. So what I'm trying to say is sometimes there are some inconsistent relations. In that case, what you can do is you can bin it. Here, since we can see the data, that's why I'm saying you break it into two parts. But most of the times you cannot see the data. That's why what you need to do is you have to break it into, let's say, 10 parts. Every time what we do is standard way, we do this into 10 parts. Automatically, we break the range into 10 parts. If you automatically break the range into 10 parts, what will happen? 5 of these parts will have, like in these parts, we will have good relation. Maybe in these 5, we will not have good relation. At least earlier, we have to ignore X totally. Now we are taking a piece of X, half of X is being used. Again, what we're trying to do here is we are trying to give our level best to increase the accuracy of the model by trying different tricks so that we can find whatever pattern is there in the final model. That's why I say that this requires a lot of patience and we have to do a lot of research to find out the improvement in the accuracy. This is known as binning or discretizing. So usually if you have the overall data range, if it is going from, let's say, 16 to 1200, okay, or 0 to 1200, instead of directly taking that full range, you divide it into 10 pieces. This is the X variable, you divide it into 10 pieces, and then try to use each piece for model building. The patterns, the pieces where there is good pattern, they will fetch some improvement in the accuracy. The pieces where there is not much of pattern, anyway, they will be ignored. They will not give any accuracy. For example, if you take square feet of living, I have a very strong impact. My client is also telling me that the living area or the carpet area has a huge impact on the house price. Do you also agree? That has to be one of the most important variable. If the house has higher carpet area, then the price must be high. If it has a lower carpet area, the price must be low. If you want to force it to be used in the model, use this Q cut option, which will do the binning. Q equal to 10, 10 bins you make it. Maybe it may not have a perfect relationship. Maybe it will not have a perfect relationship with the target variable. It may have inconsistent relationship. Wherever there are patterns, they will be found and they will be added. Apart from whatever we have done here until now, if you add one more binning variable, if you do that binning as well, until here, the best of the best R square happens to be 80%. Now with these bins, if you build the model or the best of the best map happens to be how much? Best of the best map was one hot data, not different. I think some of the, okay, this is a different one. This is the original code. Let me clear all. So until now, let us see the best of the R square is 80%, but if I do the binning of it, then the new R square happens to be how much? Okay, again, the same one. We will try to. I remember doing it. Let us see where is previous columns, encoded columns. So we will try to use the same piece of code. What we need to do is before sending it to the model, we will try to apply this on X. So convert everything into strings. Then the R square happens to be 83%. Yes, it's obvious that with one variable, by doing a little trick, we may not be able to increase the accuracy by a huge amount. But if even if it is giving 1 or 2% lift in the accuracy, if you're doing it on 10 or 20 variables, each of them will finally contribute to the final accuracy of the model. We started with 70% R square, and by doing some of the tips and tricks, by doing some feature engineering, etc., we have finally reached 83% R square. So do you think this is the best R square? We should stop here, or if we keep on doing the research, if we keep on doing the business research and some of the business logic, if we keep on studying, can we further improve it? There is a chance, isn't it? It all depends on what new information that we are giving it to the model. Tips and tricks that we have discussed here in this session, is it true that they will work on every problem statement? May not be true. Some of the trips and tricks that are worked for retail or real estate industry here, they may not work on credit risk. Some of the tricks that worked on credit risk may not work on marketing. So all these are some of the tips and tricks that will help you to get an understanding of feature engineering. But real feature engineering requires a lot of creativity. There's a lot of business knowledge that is required. We need to study the underlying data and the underlying business thoroughly to create the new features. And also if you try to do this feature engineering too much, you may get into overfitting. That's why always look at the train accuracy, test accuracy, always, isn't it? Because if you do too much to improve the accuracy, there is always a risk of overfitting, and you need to be careful with that as well. Have you understood this, everyone? Feature engineering? Yeah. What you have to do right now is you can go back to your project. That will be your last step in the project. You can apply this feature engineering, maybe at least one hot encoding, and then you will have the ultimate highest accuracy of your model. If you remember, you started with data cleaning and then you build the basic model, you will have less accuracy there. And then you have done the class imbalance fixing, and then you have increased the accuracy. Then we have seen some of the advanced models like random forest boosting. They will further give you boost in accuracy. As a last step, you can apply feature engineering that will give you the ultimate accuracy. And when somebody asks you in the interview, how do you improve the accuracy of the model? You will say that we started with this, then we did this, which is class imbalance fixing, smooth technique, and oversampling, undersampling, that improved. And then random forest boosting, that improved. Then we applied feature engineering that ultimately improved the accuracy of the model. So that will be your last step in the project that you have to implement.